Okay, back to D03, just continuing our discussion of one-dimensional friction. Okay, so we have number 3, a 4.5 kilogram sled rests on an icy surface with a coefficient of friction of 0.10. The sled is pulled by a 35 Newton force parallel to the surface. What is the acceleration of the sled? Okay, so we're looking for acceleration, so we ultimately want to find A. So A is what? Okay, so we need to first take a look. Remember, what we really want in order to find acceleration is the net force is equal to mass times acceleration. So we need to figure out what is the net force on the object and what is the mass of the object. Well, we already know the mass. The mass is equal to 4.5 kilograms. Okay, so we need to find the net force. In order to find the net force, well, that's equal to the force of friction plus the applied force. Okay, so the applied force is the 35 newtons. But we need to find the force of friction. Okay, in order to find the force of friction, okay, the force of friction is equal to the coefficient of friction, which we know, times the normal force. Okay, so we know the coefficient of friction, that's the 0.10. Okay, and then we need to find the normal force. All right, well, the normal force is equal to the opposite of the gravitational force, so negative mass times gravity. Well, we know both of those things. The mass is 4.5 kilograms, and gravity is, of course, negative 9.8, put this in parentheses, negative 9.8 meters per second squared. Okay, so our normal force is going to wind up being positive, so negative 4.5 times negative 9.8 gives us 44.1. So our normal force is 44.1 newtons. So plug that into this equation to get our force of friction. Okay, so the force of friction is 0.10 times 44.1, so which gives us a force of friction of 4.41 newtons. Okay, so then we can take that and plug it into our net force equation. Okay, so the force of friction is 4.41 newtons, and remember, it's acting in the opposite direction of the applied force. So the applied force is going in one direction, force of friction is going in the other direction, so I need to make sure and do a negative. So negative 4.41 plus our applied force of 35 newtons gives us a net force of 30.59 newtons. So our net force is 30.59. 30.59 newtons. Okay, and so then the last thing would be to then take that 30.59 newtons and plug it in for our net force there. So the net force, 30.59 newtons, is equal to the mass, 4.5 kilograms, times acceleration. So we have to rearrange that. That equation was on the first page, acceleration is equal to the net force divided by the mass. So if the net force is 30.59 and the mass is 4.5, 30.59 divided by 4.5 gives us an acceleration of 6.8 meters per second squared. Okay. Number 4, job description states that an applicant will be responsible for lifting boxes up to 50 pounds, which is approximately 23 kilograms. What force would the worker need to exert to start a 23 kilogram box in motion on a level surface if the coefficient of static friction between the box and the surface is 0.45? Okay, so we'll go ahead and draw a force diagram for this one. So we've got our 23 kilogram box. We have the force of gravity is acting on that. Okay, and then we have the normal force acting on that. It's not being raised up in the air at all. There is no vertical acceleration or any sort of vertical net force being acted on it. So our force of gravity and our normal force must be equal to each other. Okay? Equal and opposite. And we have an applied force, which is what we're looking for. What is the force that's going to start this? Okay, and then we have the force of friction. Okay, so the first step is we need to find the normal force. The normal force is the negative mass, so negative 23 kilograms times the force of gravity, negative 9.8, or excuse me, the acceleration due to gravity, negative 9.8 meters per second squared. So negative 23 kilograms times negative 9.8 meters per second squared gives us 225.4 newtons for our normal force. Okay. The next step would be to find the force of friction. Okay. Force of friction is just equal to, of course, our coefficient of friction times the normal force. Our coefficient of friction was 0.45 times the normal force we just found, 225.4 newtons, gives us a force of friction of 101.43 newtons. Okay, which means that our applied force, because remember, all we want to do is get it started. It says that what's the force needed to get it started? Okay, what force would the worker need to exert to start it in motion? Well, it needs to be anything greater than the 101.43. So the applied force must be greater than 101.43 newtons. Anything greater than 101.43 newtons will get that box started.